two chapters are kind of backwards in the text. You should have 14 instead of 13, but we don't, so we're just going to take them as we get them and come back to them. Maybe it's the best way to go through it. We'll find out. And then we'll get into 15 a little bit after that also. So tomorrow I'm going to go back through 14 and we're going to, in essence, cover this guy. Because this guy right here is really what's going to solve the two drawings that we have today. And I want to real briefly hit this so that you hear it more than once. First, the line appears true length in the viewing plane parallel to it. Okay, what does this statement really do for us? In essence, this sets up the rotation on a plane, is really what this is all about, the first one. Because for you to accurately rotate an object, you have to start with a true length line. Okay. Now, keep in mind, when I talk about a true length line, what's a line consist of? 2 points, right? Okay. Then that makes a line. What is a plane? Say this is a plane. What does this consist of? Lines, doesn't it? Yes. Lines bound it? And so therefore, if we can find any size on this that's true length, whether it's this side or this side or this side or this side, then we set these up to where we can rotate. Now, these laws right here are going to give them to you. Now, let me just try and run through a quick example. So this is going to be my viewing plane. Remember, we always look perpendicular to a viewing plane, right? Our line of sight is always perpendicular to it. Okay. Now, if I take any line, okay, so I'm going to hold it up to you folks, this is a line. And I'm going to set it up in any orientation. I'll set it up like this one so you can see the shadow. Okay. It's going to project like such. Okay. Now, is this guy true length? You really have no way of knowing. But keep in mind, if I take any viewing plane and I decide to put it, and I put it parallel to this line. Now remember, I look perpendicular to these viewing planes. Therefore, when I rotate to my view, I'm going to be looking like this. Now I'll always see that line true length. Okay. Yeah, we kind of agree with that? Mm-hmm. And in fact, we'll go through some figures tomorrow to make sure you agree with that. But it's a true fact. If I take this, no matter how I look at it, here or whatever, as long as I'm looking at it parallel, I have to see this true length. Now, keep in mind, this is attached to a plane. So we've now rotated, and let's say we've got true length of this line. What does Law 2 state? True length line appears at a point in the viewing plane perpendicular to it. So what that's saying is, you have a true length line. You're now going to put a viewing plane perpendicular to that true length line, or right here. Okay. Now, no matter how you rotate this, for that orientation, that line has to appear as a point, correct? Mm-hmm. We just said planes are lines. Now let's make the jump to a line. So if you look at this side, true size, that's fine. We can get true size. Then I'm going to look at a line as a point. So I'm going to take any line on this plane, and I'm going to rotate and look at that line as a point. How do I have to see the plane? If I look at any of these sides, and I'll just focus on these two, I'm kind of running around. If you're looking right down that thing, and you see that line as a point, what's that? I see any of those lines as a point. But a point being, I have to see this plane on edge. Okay. Because if I look at this line as a point, okay, and I'll put it right there so you folks over here can see it, and you're looking at this as a point. How do you have to see the plane? Okay. You're looking right down that line. Have to see an edge. Doesn't matter if the thing's like this, or like this, or like this, or like this. Doesn't matter. Have to be an edge view. Okay. In essence, that's what we're trying to do, is get to edge view. Then we rotate Law 3. What does Law 3 state? Any plane appears true size and shape in the viewing plane parallel to its edge view. So I've now rotated, I found true size, then I found Law 2, edge view. Now I'm going to put a viewing plane parallel to that. How do I have to see the plane? Have to see it true size and shape. So in essence, that's what this is doing right here. This is setting up your rotation of planes so that within 3 rotations, you can get the true size and shape of any plane. Now what we've got to do in our mind is we've got to make the connection between Lines that are foreshortened, lines that are true shape. How do we get to edge view? How do we get to true size and shape? And that's the connection we need to make over the next couple days. Now, to do that, we have three types of planes. We've already dealt with one called an incline. And let me pull up one of these just as a refresher. So I'm going to go to figure 13.4 on page 655. This is our inclined plane. Now, remember the rules here. I've got my three rules. Law 1 is all about finding a true size line. Law 2 isn't about finding the point view, it's about finding the edge of a plane. But if I look at any line bounding a plane as a point, I have to see it on edge. So if I'm dealing with an inclined plane, you see it right here. Here it's foreshortened, here it's foreshortened, here it's an edge. You've done some of these now. Now what did we go and do? We went and drew a fold line right here, right? We drew that plane parallel to the edge view, and then we rotated one time, right to here. What did we get? True size and shape. In essence, inclined planes are already at law 2, by definition. Because laws 1 and 2 are all about getting to an edge view of a plane. With an incline, you are already at law 2. All you did was apply law 3. You put a viewing plane parallel to the edge view of a plane. Therefore, it must rotate true size and shape. That's what you do with inclines. One rotation. One rotation. Now, let's go to the next type of plane we have to deal with, since we've already handled that one. Now, let's go to dihedrals. Page 666. I suppressed my joke there. You've already heard it once. Okay, what do they do in here with the dihedral angle? Remember, just an angle formed in space. Okay. They've got it, one rotation here, and they're seeing that thing true size and shape, that cut. How come they can get that in one rotation? Let's look at their views. Okay, so here's a front and a top. Here's a front and a top. Here's a front and a top. All three different items here. Okay, see if you're not familiar with this figure. Okay, so here we see the projection of the dihedral in our front view. Okay, so I'm seeing this open that's done with object lines. That's that cut right there. You're seeing two foreshortened surfaces. Okay. Then we see the bottom of it go through. That's this line right here on the bottom. And then I see this hidden line, which is this back one right here that's hidden from view. Okay. So I've got my dihedral angle shown here and here. Now, for us to find a dihedral true size and shape, the thing you have to focus on is the line of intersection between the two planes. Because if we can look at these planes on edge, don't we see that cut true size and shape? No matter how it appears? I got another visual aid for you. Okay, here's kind of a dihedral angle. Okay. Well, if I take this thing and I look at it where any of these planes are on edge, okay, like that, you have to see right down the middle of the cut, don't you? That's what we're trying to. Now, which line do you focus on to get it there? There's a common line between these two planes. It's this one down in here, isn't there? Mm-hmm. You focus on the line that's common to those two planes, because if I can see this line as a point, I have to see this plane and this plane as an edge, because they are both common to this line down here, the point of intersection or the line of intersection. So when we're doing this dihedral, they've applied the laws for you here. What we've got to do is just kind of look at this and say, you know what, is this line true size and shape right here? And the way you're going to know, remember there's a fold line in here. What does law 1 state? Line appears true size and shape in the viewing plane parallel to it. Okay. So If I look at this line, is it parallel to this fold line? It is. Guess what? That means that that line has to be true length right there. Has to be. Okay, 'cause it's gone through law 1. If I look at this top piece right here, that top one is that one and that one, isn't it? Okay. Is this line parallel to my viewing plane? Yeah. Guess what? Both of these are also true length in the top view. Now I've got these side cuts that are here, here, and here, which I see in here, okay? But if I look at it, is this line right here, is it parallel to that viewing plane?
No.
Okay, so there it is, and it's foreshortened in this view. This line right here, is it parallel? Nope, it's foreshortened, it's right there. This back one right here, is it parallel? Is that one? Nope, those are all foreshortened. Now, what you want to focus on is the line of intersection though. That's that one right there. Now, why am I doing this exercise? Because to get to edge view, I've got to have a true length line. And in fact, I need this line to be true length. Given the situation here, I've got a true length, don't I? Therefore, I've already satisfied law 1. I've got the true length line on the line of intersection of a dihedral. Then I apply law 2. That's in essence what they're doing here. They came and drew a viewing plane that is perpendicular to my line of intersection. What's law 2 state? True length line appears as a point in the viewing plane perpendicular to it. We just found that line was true length. We're going to put a viewing plane perpendicular to it, and we're going to rotate for that view. What do we get? True size and shape of that plane. So edge view, I guess, really is what it is, but it's true size and shape of the cut. Because we took this line, we found it true length, then we went perpendicular to it, and we see both planes on edge.
Would you repeat again why the lines up there were true length?
Because they satisfy law 1. Law 1, a line must appear true length in the viewing plane parallel to it. There's a viewing plane in between these two views. I look here, there's a line. Now that line, just so you know, is this line right here true length? Well, I look at that line, that's that line right there.
Mm-hmm.
Is it parallel to this viewing plane? No, it's not. So therefore, that is a foreshortened line in this view. What you're looking at there is you're looking at that line kind of like this, right?
Yeah.
And in fact, yeah, that's right. So it's coming this way. And so I see it foreshortened right here. But it doesn't really matter in this view because I'm not going to rotate off of it. So all I was doing was trying to find my true length line, and I really want to focus on that middle one, the line that's common to both planes. Okay. So all I did was I found that true length. I know it is right here. I'm looking at it just like this. Now I'm going to come to here, and I'm going to draw a viewing plane perpendicular to it, rotate, so I see it as a point, and I have to see both planes on edge. That's what we just did, Cheryl. That's what they're doing right here. That kind of clear that up a little? You're going to hear this many times. It's pretty confusing at the start, but you're going to get lots of practice at it. We're going to go through this process in just a moment. Okay, so I wanted to review it here. Now, we've got one other plane that we need to deal with this morning. And let's see how the laws apply to that. Let's go to the last page of the chapter. And we have oblique planes. How do we solve oblique planes? Folks, you can rotate this thing till the cows come home and probably never get it true size and shape. But if you follow the rules of orthographic or descriptive geometry, you're going to get it right every time. Every single time. Okay, so what do? Here's my oblique plane, front and top view. For them to get a rotation, first thing you got to do is you got to find a true length line on this plane. That will tell us our rotation angle. So again, here's my fold line. And what I want to do is just go through this and say which lines are true length and which ones aren't. So let's look at line AB in the top view. is this line parallel to that viewing plane?
No.
No. So therefore, it has to be foreshortened in this view. Now, let's take that same line AB here. Is this line parallel to that viewing plane?
Yes.
Okay. Therefore, that one has to be true length. So I see line AB twice. It's foreshortened in this view, it's true length in this view. Now, let's look at line BC. I see it right here, and I see it right here. This is perpendicular to the viewing plane. That doesn't really help us. All it tells us is that this one must be foreshortened. This one's perpendicular. It's not parallel, so that's got to be foreshortened also. Then we look at line AC. Is it parallel? No. This is foreshortened. Is line AC parallel to the viewing plane here?
Yeah.
So this one is true length. I've now found two true length lines, one in each view. So line AC is true length. I can rotate off of this and get true size. I now know the angle. I know this is true length. I can rotate off of this and get the exact same angle I would get the same size if I rotated off of this. I can just go this angle. The author chose to go this way. Okay, so there's true length line. What did the author do? Drew a fold line perpendicular to the true length line. Therefore, I have to get line AB as a point. I'm just going to bring point C with me. Now I see edge view, right? Okay. Now I've got edge view. I've now done law 2. Now I need to apply law 3. Plane appears, true size and shape, the viewing plane parallel to it. That's what they're doing here. They come over to here, they draw the viewing plane, project in, and true size and shape. 3 rotations for obliques. Now, we only had to do 2 because we had a true length line given to us in our orthographic projection. If this was not true length, or that wasn't true length, you would have to first rotate for true length, then edge view, then full size and shape. Okay. So we just apply those laws. They tell us the exact angle to turn that thing so that we can find true size and shape of these items. Now, there's one other thing let's go into before we jump to the computer and practice this. How do I build a view like this one, which is a secondary auxiliary view? Where do I get the missing information for? Because we're outside of the laws of orthographic projection now, right? We're not set up in our nice little box. We don't, what's related, what's adjacent. In fact, what I tell you is you always work 2 back. So I got this view and this view. I would use these 2 to create this view. Now, how I do it, I've got edge view. I make sure I know my points, A, B, C. I'm going to draw that viewing plane. Law 1 of orthographic projection, we can then take and shoot those lines perpendicular to that viewing plane, correct? Okay. We still do that. Now, we know points A, B have to fall on this line, point C on here, but where? How do we know where? Well, you go back to your second view. The distance from viewing plane to B will be the same viewing plane to B. Okay. So we go back to a related view that's 2 back. Distance from fold line to A will be the same as fold line to A. Fold line to C, same as fold line to C. That's how we get the missing dimension. Once we find those points, we just digitize the shape around, join our points, and we've got it. Okay. Is that like a bunch of Greek?
Yeah.
Maybe. Some of you are saying, yeah, I got it. Some of you are saying, well, maybe I need to let this one stew for a little bit. Let's practice it. Okay? Let's practice it. Keep in mind, like I said, all of this information with these laws is really in the next chapter, even though we need to apply it in this chapter. So let's go and let's start with the dihedral, which is actually the easier one. at least with fewer rotations. So if you would open the one that's labeled dihedral. Hey, first off, I got a real quick error on this. I've kind of changed it a little bit. These two holes there that are on this, those aren't there. Just delete them. We're just going to focus on the dihedral angle here. Okay, first let's make sure we understand the drawing. So I've got a front and a right side. I've got planes AE. I see them foreshortened in this view. I see those same planes right here, where here's the bottom, here's the cut that's this back side, here's the cut I can see, which is this side.
Oh, okay.
We need to display this cut true size and shape. Focus on the line that is common to both planes. So what we're going to do here, folks, is we're going to look at this line only, because that line is common to both plane A and plane B, correct? Okay. Now, what I've got to ask myself, because I'm getting ready to rotate for it, I know I'm going through the 3 laws of orthographic projection with a dihedral angle. I need to get to edge view, so I apply laws 1 and 2 on all dihedrals. Law 1 is all about finding a true length line. Do we have a true length line of this dihedral angle? Remember, there's a viewing plane right here.
Yes.
Carol, you said yes. Which ones on my front view are true length?
That would have to be the center one.
I would say all of them are. How come all of them? Let's start with the bottom one. That's this one. This is the one we're going to care about, this guy, one in the middle. That's right there, right?
Yeah.
That is parallel to the viewing plane, therefore it must appear true length in this view. The top is this piece. Where does it run from? It runs from pretty much the whole length here. It's here, it's parallel, true length. The other one's underneath it, it's true length also. They're all true length here. So what we want to do is focus on this guy though again. That's the line that's important. So let's go ahead and create this view. Now, the thing you want to do, because we need 2 views to create it, is you want to set up a viewing plane. So in between these 2 views, it doesn't matter where, I'm going to put a viewing plane. So I'm just going to draw it. And it doesn't matter where it really is, right here. Okay. So put a viewing plane in between your front and right side view. And that will just be a vertical line. Now the next thing we have to do is we need to create a viewing plane for this cut. And we can go any direction, but we know that the middle line is true length. And I need a viewing plane perpendicular to it. So what I'm going to do is just draw a line, and I'll just click out here. I'm going to use my perpendicular snap to get perpendicular to that front view, and then I'll just move this a little bit so that I'm with the object. I'm just going to put it about right here. So just so you see what I did. I did another viewing plane where if I was to project that out, that's going to be 90 degrees. Okay. And it doesn't matter where that thing is. Hey, is everybody there? Okay, next thing. We know that these lines on these planes have to project perpendicular to this, right? So I'm just going to set myself up a line that goes quite a ways here. I'll come, let me go. You can set up angles different ways, but I'm just going to make it perpendicular to that guy, and then I'll move it to here. Okay, let me change the color of this. I'll do white on these. Okay, so I'm setting them up like such. So I projected this line, and this line. Keep in mind, there's always 90 degrees where you cross that viewing plane. Raise your hand if you need a little more time. Okay. Everybody there? All right, so now, in essence, what we're doing here, folks, just see